everyone, welcome to my channel. So today we are going to do Leetcode daily challenge and its name is construct string from binary tree. So basically in this question we are given with a tree, and in that tree we are basically required to construct a string out of that. So the thing is that tree is basically on the basis of tree nodes, means it's all on the basis of pointing towards a new node and so on. But we are now required to get all those values from that tree and then construct a linear string out of that. So that is the thing. Main challenges which here would be, that's all in the basis of checking for that where the null lies and how we are required to get rid of that particular null at some specific positions as per the examples which is being given to us. So let us first read the question, then constraint, and then get to the examples. So here, given the root of a binary tree, construct a string consisting of parentheses and integers from a binary tree and with the pre-order traversal way and return it. Is my screen visible clearly? Yeah, now much better, I guess. So, omit all the empty parenthesis pairs that do not affect the one-to-one mapping relationship between the string and original binary tree. So basically, when we are having a leaf node, then its children would be directly null only, right? So they just want to say that we are required to omit all those null nodes which are being there. With we are omitting that, and we are required to not omit those null nodes which will be changing the structure of our binary tree. Basically, if we see, means 1 is there and then 2 is there. Here we are having a null node. Okay, so here we can't omit this particular null node. We are required to take it. But if the thing was like this, then we can omit this null node. This will be eradicated. Means even if we make our string something like this, then it will work. But if we make our string, if we don't use this null here, then surely both of them will become equal only, right? And this thing we don't want. So that's why here we require this null node. So that is the only thing which we are required to keep concern in this particular question. Else everything would be fine, like traversing the tree and then getting the nodes out of that, and after getting those nodes, then putting those nodes into the brackets, and after putting those nodes into the brackets, then we will be moving ahead and checking that if there is some null node or not. If there is some null node, then we will go ahead with the same and check that does it change the structure of the tree by removing those null nodes. If it doesn't change the structure of the tree by removing that null node, like it was in this scenario, then we will remove that. If it changes the structure, then we will keep it. So this is the whole thing which we will be doing in this question. So yeah, this was the explanation for this, and although explain the crux of this question which we are required to go ahead with. But yeah, let us first check for the constraint. The constraint for this question, as you can see, is up till 10 raised to power 4, means the number of nodes which are being there. So if we do n log n or even the n square, all this would work. But as it is a tree, so we all know that in a tree we can do BFS or DFS. So it usually takes till at max order of n time. Means usually in some scenarios it could go till n log n or sometime n square also, as per the question. But here, as we will be just doing the traversal of the tree but here I will be preferring with the DFS approach, and in that DFS also the pre-order traversal, so that at the first moment only we will be processing the node and then we will be traversing towards its left and the right side. So that's the thing I will be doing in this question. And then the nodes value are also, some are the negative and some are the positive. So basically it is an unsigned int range. So now the thing is, even we are just required to convert them to string, right? So your node values won't matter much, but the part of that minus, but when we convert those negative to the means, but it would be already stored in a node value, right? So when it is already stored in a node, so we are required to take it in such a manner that we can easily store them up. So that would be the scenario here. So now that was all. So let me explain you more clearly about this question, and then we will code. So now this is the first example, I guess. Yeah, this is that first example. So how we need to think about each node is, means while traversing, how will we going ahead is, first we are having this one, right? So for this one, what are its subtree? So its subtree is basically 2 and 3, right? So how we will be writing them? So for 1, then it will be written as 1, then in the bracket our left subtree, and then in the bracket our right subtree. So this is how it would be written. Then comes the part for the 2. As we are doing pre-order traversal, right? So in our pre-order traversal only, it will be it will be taking care of all our subtrees by that side only. Means it will be first concerned with the root node. So it will be something like this only. Then it comes the part for the 2. So for 2, we can see its subtree is 4 and null, right? So how we can write 2 and 4 and null? It will be something like this: 2, then 4, and then null. Now here comes the part that we encountered a null bracket, right? So in this particular portion, then we check that if we remove this particular null, means basically this empty bracket, right? So does it changes the structure of my tree? Because this is at the rightmost portion, means this null is at the rightmost portion, and the rightmost portion is the endmost portion for a particular subtree, right? So it won't even affect my tree. So that's why for all the rightmost empty empty brackets, we can eradicate those rightmost empty brackets. So that's why we have removed those, and now our answer would be 2, 4. So this 2, 4 would be returned to this particular bracket basically. Although I was showing you that how it is required to end, but here comes the part that here we will be concerned about some more things which this 2 subtree will return and which this 3 subtree will return. So that will make our final answer. And then this was for 2, and now comes the part for 3. So 3 is having both of them null, right? So our 3 would be written like this, and the final answer would be 3 itself. That's the thing. So basically for our this subtree, the answer would be something like this. Means at the start it would be like this, and then in this particular 2 and 2 would be come up, and in this particular basically 2, and inside that 4, and in this 3 will be there. So the final answer would be something like this, means 1, then 2, 4, 4, and then here it would be 3. So this is thing it will be going ahead with. So now let me show you another example which they have given to let us know the value of empty bracket and where we are not required to keep it. So this is all. So yeah, here you can see, let me change the color also. So here you can see in this particular, we are having our subtree as 1, 2 and 3, right? So in this 1, 2 and 3 we can write directly like this. So basically at the starting, this I'm just showing you that if it is a subtree like this, then, but in this question, if we take the whole subtree, then in that particular context, the thing would be something like this: 1, 2. Basically at the starting, the bracket would be something like this, right? And in this particular context, we would be getting a left subtree and right subtree. So our left subtree is this one, right? So in this left subtree we have 2, null and 4, and then this is there, right? So this will be in this answer and this will be in this answer. So that is the thing. So here for our left subtree for the 1, we are having null and then 4 is there and our 2 is there. So we will be writing like this. Here we can't eradicate this null empty bracket. It's all just because of this fact, because if we eradicate that empty bracket out of this for eradicating the null value, then it won't work for us. It's all because of the fact that if we remove this particular bracket, right, then our structure of the tree will change. So that's why when there is a left empty bracket, then we will keep it, but when there is a right empty bracket, then we will eradicate it. So this is the whole thing which we are required to do in this question. And then for this particular, when we are having both left and right as empty, then in that context, we will be eradicating both of them and just keeping our tree. And then that will be in our answer. So our final answer would be something like this, 1. And then from our left subtree, we got 2, then our empty bracket, then 4. And then from our right subtree, we got just 3. So this is our final answer. And this is how we are required to do our whole question. So from these 2 examples only, we got to know that if there is a null towards the left side, then we will keep that bracket. In this context, you can see, because if we don't keep our empty bracket at that moment of time, then surely we will be transforming our tree structure, which we don't want. But if we have both null values, basically this is a leaf node for time being, then we will eradicate both of the empty brackets. Or if we have some case like this, the way it was here, so in this scenario, we are having a null value here, right? So in this scenario also, we will eradicate this empty bracket. So this is all about this question. Now comes the part that how we will code this question. So as you can see that if we do processing of our node, basically a root node at the starting itself, right? So it would become much easy for us, so that at the starting root node, we have the empty brackets for us, and in those empty brackets, we will be filling our values for the left subtree and the right subtree, and then for those left subtree and those right subtree will be having their own left subtree and right subtree, which will be filling their own values. So as it goes down and down to the subtrees, then it will be easily able to get further values. So this was all about the explanation part. Now comes the part for the time complexity and space complexity. That would be order of n only for both time complexity and space complexity, because you can see that in this particular tree, here if it becomes somehow a skew tree, right, then in that particular scenario, its height of the tree will directly become equal to the number of nodes of the tree, right? So that's why in that scenario, we will be required to traverse all the nodes rather than just the log n nodes. So that's why the time complexity of the solution would be order of n, but the space complexity, that would be order of n, and reason again is for the skew tree itself. So this was about the explanation part. Now let us go through our coding part. So in coding, we will be doing the pre-order traversal. So in that pre-order traversal, and that also in the form of DFS recursive approach, not the iterative one. So now here comes the part that if we encounter a null node, so that's for sure that at that moment we will be returning empty string, right? So that's why we are returning here as empty. Now comes the part we require the string values, right? So for that part, in every root value, we are first directly converting it to a string. And then next comes the part for our left subtree and the right subtree. So for our left subtree, we are basically checking that in our left subtree, we can check, the first thing is for all the left and right nodes, we can check that first we will be having the bracket so that we can have our value inside this bracket, and then we will be calling our left node by our function, and then we will be having another bracket, and inside that bracket we will be having our value which will be there. So this is that case when we are having a left node. If we don't have the left node, but in that scenario we are having a right node, right? So this is that scenario that when that leftmost node is not the leaf node, but it is a node. Basically, this is the thing. Means when we were having this, what was that? Yeah. Here you can see we were having basically null at the left side, right? So I'm talking about this case that if my this left side doesn't exist, but my right side do exist, as you can see here, then we will be having an empty bracket. So this is the thing which we will be required to return. So that's why we have written this. That if left exists, then we will be doing like this. If it doesn't exist, then we will be doing directly like this. But if our root right exists, then in that particular criteria, because if our root right exists, so in this we don't need any else case, because if it exists, then surely we will be having our bracket, then our call, and then again our closing bracket. Here we don't need to check that if there is some more, because it is by itself, either it is a leaf node or it is by itself an ending node, right? So that's why we don't need a else case for the same. And at the end, we will be returning our string. So this was all for this particular question. And I've already explained the time complexity and space complexity. So if you like the explanation, please do like and subscribe to my channel, and please do share among your friends. So yeah, this was all. Thank you.